Yet if you did x cubed times x squared times x cubed times x to the fourth, you add those up, don't you? X to the 12th. And all that matters to you is that that's an even power. So we have an even power. What's the leading coefficient? 1, because all those were 1s in front. So this should do what? Up, up. Step 2. We set each of the factors equal to 0, right? Because it's already factored out. So we set x to 0. We set x plus 2 to 0. We set x minus 7 to 0. And x plus 12 to 0. And you're going to get 4 answers here. What is happening at x is 0? Cross or bounce? Cross. Right? That came from here. That's odd, so you're going to cross. What about at negative 2? That came from here, right? Even? Bounce. 7, that came from here. Odd? Cross. And finally, at negative 12, that came from here. It's even, bounce. And it's graph time. Put all your x-intercepts, negative 2, 0, 7, and, oh, oops, negative 12, not positive 12. I'm on the wrong side here. Notice that I really didn't even measure out like how far things were. That's fine. You don't need to put like little tick marks for every single thing. You can just make sure you get them in the correct order. That's the most important thing. Okay, what comes next after I put all the x-intercepts? The 2 little arrows. So I'm supposed to go up over here and up here. Now let me explain why I am not telling you to attach these yet. See, if I attach, let's say I attach this. Let's say I did that. Right? Then what am I supposed to do at negative 12? I'm supposed to bounce, right? So now when I go to draw this, like I have to bounce up. It may start looking too much like a corner. I don't know if this makes any sense to you. By me drawing it like this, when I come in here, I know it's going to bounce. I can actually put a little bit of a curve to it first. Does that make sense? It just helps my picture look nice and smooth so I don't have to draw it over again. Now, what's going to happen when I get to negative 2? I'm going to bounce again, right? So I'm going to have to come up, doesn't matter how far. Come up, come down here. I'm going to bounce off again. And then at 0, I'm supposed to cross. So I'm going to come up and cross through. And then when I get to 7, I'm supposed to cross. And that's a good thing, right? Because when I cross through, I'll be able to reach that other side. That. There's my picture. So we just graphed. This is actually a 12th degree polynomial that we just graphed. We did a quick sketch of it. Okay, what's your feeling here? Now your homework for this is not out of the packet, all right? Because the packet, well, it's almost an insult to the subject of mathematics what they do with polynomial functions in here. It's one page, and all they do is talk about what the graphs look like, and that's it. There's not even anything on graphing them or anything like that. So that means your homework I'm going to put on the board. I'm going to just give you a set of problems to work, all right? So why don't I put those up now? Unless you feel like you need more examples. You're basically going to have, when it comes to polynomials, two types of problems. I'm either going to give you a function that's not factored, that you're going to easily be able to see the leading, like the end behavior, but then you're going to have to factor it and then figure out cross bounds. Or I'm going to give it to you already factored, which it'll just show you what cross bounds is, but you have to actually figure out what the leading coefficient test tells you. So it's one of those two types. It's on there?
Yeah, 87.
Why, man, something is up with my packet. I even went and tried to update it, and it's 87?
Mm-hmm.
Oh, yeah, okay, cool. You know what? Yeah. Page 87 will work. Yeah, but the problem with 87 is it doesn't give you any that you have to factor. Right? Yeah, so everyone, for homework, make sure you do page 87. Thank you for pointing that out. And then let me add a few more to that. See, notice on 87, they're pretty much, with the exception of number 8 and number 10, they're already all factored for you. I think I need to, I'm looking at that page 87, and there's something we should talk about. Just curious how you would handle this. Let's run through this one real quick, because I see this becoming potentially an issue here for you in the homework. If you were asked to sketch this, it's already factored, isn't it? Yes. Remember, this is like a -1 out here, isn't it? Okay. So can you tell me what the degree of this is? And I mean, looking at these x's and figuring out what the powers are, what is this really kind of acting like? X squared? And this one is really acting like what? X? But there's one additional thing here that we have to take into account, that -1. This -1 does have an impact on everything, doesn't it? It makes everything negative. So this would be like a -1 in front. So that would really be like -x cubed. And that means it would go like this and like that. Now, when it comes to finding the x-intercepts, how many x-intercepts do you have? You set this to 0, right? You get -4. You set this to 0, you get -3. This, you don't set it equal to 0 because that doesn't have x in it. So you just ignore this. So you're going to have two x-intercepts at -4 and at -3. And what do we do at each of these? What do we do at -4? You bounce. And at -3, you cross. And those are coming from this number, bounce, cross, right? So my picture would look like this. Goes up on the left and down on the right. Got to bounce at -4. So bounce here, come up, cross through, come down. Now on the page 87, I believe all they want you to do is match the graph, but you should do this. You should do it by hand and then match it, right? Don't be like going to a computer and typing it in and graphing it and matching it. That's not going to help you on a test, right? Does this seem within reason to you all? Yes? Okay. That's plenty of practice for those. Let me give you a few that you can factor yourselves as additional supplementary homework. And let me kind of give you an idea of how I create these problems, all right? So don't write this down, but that's a quadratic that everyone here should be able to factor with the AC method. This becomes x minus 3, x plus 2, right? So when I'm making up these problems for you to graph for these polynomials, what I usually start with is a quadratic. And then all I do is I get a GCF and multiply it through. So like I'm going to multiply this through by negative x squared, okay, and see what I get here. I'm going to get negative x to the 4th plus x cubed and plus 6x squared. So now if you take x, if you factor out a negative x squared from that, you're going to get that, right? And then that will break down. So you'll have your negative x squared sitting out front. Negative x squared, then this factors, then you got your thing and you can go with that, right? That's how I make up all these problems. I usually start with something I know you can work with and just distribute something through it. Okay, so you can practice that one. How about this one? Let's go 9x to the 5th minus x cubed. So negative x to the 5th. Minus 8x to the 3rd. Oh wait, hold on, that's not going to work. X to the 4th. And then plus 16x cubed.
Is that homework?
Yeah, this is homework. Just wondering if I should give you any more. One more. One more. Okay, hold on. Give me just a second.